Besides being a database, Redis is also a message broker that supports typical pub/sub operations, and this story will dive into the world of pub/sub in Redis and explore its capabilities and limitations. So let's get started. Pub/sub stands for publish and subscribe. It is a pattern in computer programming that involves allowing messages to be sent from one component of an application to one or many other components without those components being directly connected or having a direct relationship with one another. Think of it like a radio broadcaster. The publisher broadcasts audio and the subscribers listen to the audio being broadcast. The publisher does not need to know who the subscribers are, and the subscribers do not need to know who the publisher is. The only thing that matters is the message being broadcast. In pub/sub, components can send messages to a central topic or channel, and other components can subscribe to the channel to receive those messages. This allows for decoupled communication between components and makes it easier to manage the flow of information in a complex system. Pub/sub in Redis. Redis implements the pub/sub pattern by providing a simple and efficient messaging system between clients. In Redis, clients can publish messages to a named channel and other clients can subscribe to the channel to receive the messages. When a client publishes a message to a channel, Redis delivers that message to all clients that are subscribed to the channel. This allows for real-time communication and the exchange of information between separate components of an application. Redis pub/sub provides a lightweight, fast, and scalable solution that can be used for various use cases, such as implementing real-time notifications, sending messages between microservices, or communicating between different parts of a single application. Synchronous communication. Redis pub/sub is synchronous. Subscribers and publishers must be connected at the same time in order for the message to be delivered. Think of it as a radio station. You are able to listen to a radio while you're tuned into it. However, you're incapable of listening to any message broadcast while your radio was off. Redis pub/sub will only deliver the message to connected subscribers. This means that if one subscriber loses connection and this connection is restored later on, it won't receive any missed messages or be notified about them. Therefore, it limits use cases to those that can tolerate potential message loss. Fire and forget. Fire and forget is a messaging pattern where the sender sends a message without expecting an explicit acknowledgement from the receiver that message was received. The sender simply sends the message and moves on to the next task, regardless of whether the message was actually received by the receiver or not. Redis pub/sub is considered a fire and forget messaging system because it does not provide an explicit acknowledgement mechanism confirming that the message was received by the receiver. Instead, messages are broadcast to all active subscribers, and it is the responsibility of the subscribers to receive and process these messages. Fan out only. Redis pub/sub is fan out only, meaning that when a publisher sends a message, it is broadcast to all active subscribers. All subscribers receive a copy of the message regardless of whether they are specifically interested in the message or not. Now that we've seen how Redis implements the pub/sub functionality, let's put our hands in the fire and see how it works in practice. Let's do it. Everybody, let's put our hands in the fire. As you can see, I already have my instance of the Redis server running locally in a Docker container. If you still don't have one, if you still don't have a Redis instance where you can play with, don't forget to watch my video where I show you how we can spin up quickly and easily a Docker container with the Redis stack within it. But without further ado, let's continue. What we're going to be doing here is we're going to open 3 different connections with our Redis server. Let me open 3 different terminals here. 2 of them, which are those in the left, are going to act as the subscribers, while the one in the right is going to act as the publisher, right? So the first thing you're going to do is in each one of them, we're going to connect to our Redis server. I'm going to be doing it using the Docker command docker exec that allows me to execute a command within the container. And this command is going to be Redis CLI, while the container is Redis stack. This is the name of my container. I'm running this command within my container to connect within the Redis command line interface. I'm going to be doing this in all of them. Okay, all of them are now connected. Good. And what I'm going to be doing here in this one is I'm going to subscribe to multiple channels. You see that the subscribe command can receive multiple channels as the arguments. I'm going to be subscribing to the crazy channel and also the cold channel. Cool. You can see that we received back two different event notifications. They are both of the same kind. Subscribe. This one subscribed to the crazy channel and this one subscribed to the cold channel. And the third element of this event notification is the number of channels that are subscribed by this subscriber. So you can see that for the first one, it was 1, and for the second one, it was 2, right? While in our second client, what we're going to be doing is using a different command, which is the psubscribe, that instead of receiving the channel's name, it receives patterns, right? So in this case, what we're going to be doing is subscribing to all channels whose name ends with _channel, and also all channels whose name ends with _chat. Okay, you can see that the same thing happened, but now we have a different kind of event notification and also patterns instead of actual channel names. And now that we have both of our subscribers subscribed to something, let's get to our publisher and publish our first message. So publish to the crazy channel the message, this channel is hella crazy. Okay, press enter. And you can see that this message has appeared in both of our subscribers right away, right? This is a new event notification. This time it's saying that we received a message in the crazy channel and that the message was this channel is hella crazy. And the same thing here in our second subscriber, right? Now let's try to send a different message, but now to a channel that is only subscribed in one of our subscribers. So this time we're going to be sending a message to, let's publish into the docs chat. Woof, woof. This is going to be our message. Woof, woof. Oops. Okay. And then we can see that the first subscriber didn't receive anything because it's not subscribed to the dogs chat channel, right? While the second one, since it's subscribed to all the channels that has _chat as the suffix of their name, it actually received the message. So you can see that it received a P message in the dogs chat, woof, woof, basically. Okay, another thing to bear in mind is that you don't need to create channels manually, right? You just need to subscribe to a channel or publish into a channel, and Redis will do the rest for you automatically. You just need to worry about publish or subscribing to channels. And all right, that's basically it. Super simple to get started. You can see that all you need is a Redis server and a few clients to connect to it and publish messages and subscribe to messages. Super easy to get started. You can also do it through the most popular programming languages, Java, Python, you name it. And yes, that's it. Let's jump to the conclusions now. Redis provides a simple and powerful solution for real-time messaging systems through its pub/sub functionality. It's lightweight, easy to implement and integrate into existing systems. It can also support a large number of subscribers and handle high volumes of messages with low latency. Besides that, messages are delivered in the order that they are published. It is important to note that the use cases are limited to those that can tolerate message loss and that don't require explicit acknowledgement of messages by the receiver. These limitations should be considered when determining the suitability of Redis pub/sub as a message broker for a particular use case. However, these limitations can be overcome when using Redis streams, the subject of our next video. Stay tuned. My name is Rafael Delio. If you like this video, please don't forget to subscribe to the channel and hit the like button down below. See you around.